Okay, good afternoon. Well, let me move there because I need to equilibrate the center of mass of this room. So we stay here. Okay, thanks for being here still. I'm Giovanni Lucivero, CEO founder of QSENSATO and also professor at the University of Bari, which is a partner of the NQSTI consortium. We are the first startup in quantum sensing in Southern Europe, and that's also because that is the result of a research, 10 plus years of research. So very briefly, I can tell you something about my own quantum to business trajectory. And after a PhD in photonics at the Institute of Photonic Sciences in Barcelona, I did a postdoc in the world leading group in optical magnetometry at Princeton University in New Jersey. Then back to Europe as a postdoc again at TICFO in Barcelona, I started to develop integrated atomic quantum sensors. And also there we started a collaboration with the CNR EFN Institute in Italy to develop what is today the technology behind our startup. Then thanks to NQSTI, the national hub on quantum technologies in Italy, I came back to Italy at the University of Bari, where I now lead the group in atomic quantum technologies. It's called Accutech. And last year we launched the startup QSENSATO. And we are based in Bari in Southeast Italy. So now I enter a bit in a pitch mode, and this is the problem we are trying to address. So many critical industries require extremely precise, portable, and robust sensors. So sensors that need to be very sensitive, at the same time miniaturized, and can be mounted on, for example, movable platforms. However, most of current solutions are often bulky, expensive, and very difficult to scale. So our solution is based on atomic quantum sensors. Here we have atomic vapors confined in millimeter scale vapor cells and manipulated by laser light to make them very sensitive to different physical quantities. For example, we can develop magnetometers to measure, these are called OPMs, optically pumped magnetometers, used to measure biomagnetic fields like those generated by human brain, heart, and muscles. Or we can detect very tiny also magnetic fields from microscopic samples in lab-on-chip devices. Then, as you know, atoms are also used as sensors of radio frequency electric fields, so we can make miniaturized antennas, and we can also define frequencies and develop atomic clocks for space applications. Also, in metrology, we can develop on-chip atomic frequency references to stabilize laser sources. So current vapor cells are based on glass blowing or MEMS. These are miniaturized cells that are already scalable on a wafer scale. However, they are based on anodic bonding between hybrid glass and silicon wafers. Our technology instead is based on femtosecond laser writing in transparent materials, and this gives us 3D versatility and multiple optical access of these devices. Also, this can be done on multiple materials, increasing the number of possible applications. And we have a European patent also approved, granted in US, on this new fabrication method, and also on devices that we call laser-written vapor cells. And thanks to an exclusive license to QSENSATO, now we can do the rapid prototyping, and that's what we're working on, of these cells on a wafer scale, and also work on the integration with photonic structure to develop what we call atomic-photonic chips. In fact, our first product will consist of atomic-photonic chips made through these innovative technology of laser writing. And then in a second phase, we plan also to develop full sensors that are enabled by these chips. The market is the one of quantum sensing that, as you know, is part of quantum technologies. That's why we are here and tomorrow at this conference. And this is also part of the global sensing addressable market. So once the technology will be mature, then we will enter also this larger market. And our first clients will be research groups and quantum startups in business-to-business models, and then also large companies and national centers. And we have a number of starting pilot partners in the biomedical sector and also in space applications. We also got some public funding, for example, to develop these vapor cells for magnetoencephalography, and from some houses of emerging technologies in Italy. We have a board of 5 members that include our pre-seed investors, Lifty and Quantum Italia in Italy is the first vertical on quantum technologies led by Quantum Nation and Scientifica. And thanks to this funding, we also hired the first 2 key people in the team, and we have also administrative and legal support. So we are in this phase of incubation. We got $500,000 pre-seed round and also about the same amount by public fundings. And we plan to have an MVP the beginning of next year, 2026, and to validate this business model based on custom designed laser written cells for different quantum sensing applications. And we plan also a new funding round in early 2027 to start developing the whole sensors, increase our team and product portfolio, and to enter this global sensing market. We won some prizes also, including this Call for Ideas Super Sapiens Europe. Here is the Embassy of France in Italy, where we got this prize from the French ambassador in Italy. And back to the technology, what we really want to do is to combine what you see on the right. These are photonic chips. So a lot of people, research groups, are working on different platforms like silicon nitride polyboard glass to develop photonic integrated circuits, PICs, for photonic quantum computing, but also for like quantum and nonlinear optics. While here to the left is the less famous wafer with atomic chips. These are these MEMS cells I was mentioning before. So with this technique of femtosecond laser writing, we can write both waveguides, photonic structures, and hollow microstructures that are our atomic sensing chambers. And that's what we can do now. This is a first prototyping run. We can do these transparent vapor cells with different geometries. Here you see hundreds of a cell from a 4-inch wafer. There is also another company in Italy doing something similar, but for photonic quantum computing ethos. And so the idea is to merge these 2 emerging technologies of atomic quantum sensing and integrated photonics. We are a spin-off of the University of Bari, so I also lead a research group, and this is, I think, in this incubation phase, can be mutual beneficial for the startup and the group. And with this, I thank you by saying our motto, that is, atoms will always be atoms.